Okay, welcome back. So today we are going to talk about the command line. We're going to begin our brief segment on tools. So before getting into any coding, we're actually going to just work on tools because that's kind of the goal of this course is to actually get your hands dirty working with system software. So we're going to use the command line in this class. Homework 1 is going to be due Friday because it's an academic activity, but typically all the rest of the homeworks will be due the following lecture. So today homework 2 will be assigned. And also, if I didn't point it out last time, the readings they're not too bad, they're not too long, so these readings are assigned on the day that they're listed here. So hopefully everyone did the Emacs tutorial. Did everyone do the Emacs tutorial? Okay, a couple people did. Doesn't take long. It'll help you also navigate the command line because the same shortcuts are used in the bash shell that is the default on Eustace and lots of Linux machines. And so today there'll be some reading on intro Linux stuff, this Linux programming interface book. Did anyone have trouble getting the book? Did anyone get the book? The books? They're free and online. So just go down to textbooks here, click on the link, sign in with your UCF account, and go to the download PDF links for each chapter. And the list of chapters to download for this class are here. And so all the readings are listed here each day. Any questions, thoughts, worries, concerns? Okay, let's get into the command line. So one of my kind of goals of this class is get everybody comfortable, at least comfortable with the command line. And so I've actually incorporated into the course where we're going to just give you a crash course if you've never used the command line before, a crash course in how to get started, how to run things, how to use some of the power of it, how to manipulate the file system. Okay, so really basic, bare bones. I've got some instructions here on how to connect to Eustace from your own operating system. There are guides here for using SSH from their own operating system. Has anyone done this yet? Has anyone actually connected to Eustace with the machine? I think, a lot of people use it for previous courses, so you should be set up. But just in case, go to these guides. It'll help you get set up. It's very OS specific, the tools you use. But once you're on Eustace, you have the same environment. So everyone has the same Linux-based, Unix-based GNU environment. So this is what you run in order to log in. And I'll actually follow along and show you what this looks like. I'll actually log in myself. Here's my command prompt. Let me just give a little extra space. Now I've been very clever and I set up myself with the SSH configuration so I can just type Eustace, or no, I can't. I can't connect. Maybe I should actually follow my own instructions. Okay. So this is just so I have my own setup here. You don't need to do any of let me see what I've done wrong. Oh no. Can anyone else connect to Eustace? Is it just me? Oh, telling you the same thing? Oh, Eustace is down. It seems. That's unfortunate. Okay, well, I'm running Linux on my machine with a similar or the same operating system, so I can show you this stuff locally as well. So I don't have to use Eustace to do this, but that's unfortunate. So, and did anyone? Is anyone? Yeah, everyone's getting the same issue. Trying to connect to Eustace. Well, I guess it's up. I mean, it is connecting. Did anyone successfully connect? You did? What's that? Oh, you're on it right now. All right, so maybe it's me. Oh, okay. So, all right, let me leave that in the background. It's doing something different now, so. All right, but anyway, I don't need it to show you the command line because I have a similar environment here for the most part. Yeah, something's wrong with Eustace. Okay, so that's logging in a lot harder than I thought it would be on this slide, but. Okay, so when you log in, you'll see a command prompt like this, where it has your NID at, and this is the host name, the kind of local host name of the server. And this is the command prompt. This is the default one in Bash. You get this little money sign, and also the current directory you're in. And I'll talk about what that tilde means in a little bit. Okay, it's actually logging in very slowly. So typing commands, if you've never done this before, you just, at the prompt, type the name of a program you'd like to run and hit enter. So that looks something like, let me go here. If I type ls on the command prompt and hit enter, voila, it gives me all the files in that directory, just like your File Explorer or your Finder in the Mac world. And Eustace is still logging me in, okay.
How do you clear the page?
That's a really good question. Let's look at my next slide. Control L to clear is how you clear the page. So if you've ever typed clear, so people type clear, Control L will do it for you, at least in Bash. Still logging me in. So yeah, so the one benefit of the command line is there's a bit of a learning curve, but you can be really, really fast at doing certain tasks. So some things GUIs are really good for, but there's some tasks where you can get really, really fast, much faster than even like a graphical Finder application. So there's also one important thing. You'll see this a lot in scripts I give you, comments. So just like in C, // for comments, or Python, you have hash sign. You have these in Bash as well. So if I put hash and type something here like ls, you'll see nothing happens because this is just a comment. So if I type ls and this runs it, etc. ls is going to be run. All the stuff after the hash, including the hash, is going to be ignored. So small thing, but really useful because in my scripts I give you, I'm going to put comments in there. You should always comment your code, right? So you won't be confused. Some students just didn't know what the hash mark meant. All right, that's hashes. All right, let's go over basics of the file system hierarchy. I know for some of you this might be like old news. Some of you this is very, very new. So I just want to make sure everybody's on the same page. So unlike in Windows, the / is the path separator in the Unix world. And also unlike Windows, there's a single root directory. So in the Windows world, you've got like C drive, D drive, etc. This goes back to the really old, kind of when it was like the very old PC days when you had individual devices being connected. The Unix philosophy is there's a single root of your file system, and that's represented by /. And then directories are separated by / as well. So if I put /usr, which is abbreviation for user, /bin, these are 3 different directories. We have the root directory, we have the user directory, and we have the bin directory. Other conventions in the Unix world, there are 2 special directories in every folder. There's the dot directory and the dot directory. Has anybody ever seen these before? You probably saw if you ever had to like run your C program, you compiled like your oh, this is on Eustace, which I can't connect to. Wow, something's very wrong. Oh, now I'm logged in. Okay, great. So if you've ever like compiled your C program and then we're like, well, I'm trying to run it with hello, but it won't run. I can't run anything actually, but I have to do /hello. Everyone had to do that before? Some people? Dot just means your current folder, and there are some good reasons why you have to do this, but so you don't conflict with system installed binaries. But // is just your current folder. It's just a reference to your current folder. All right, so let me give you an example hierarchy, just so we can follow along when we're doing like file operations. Okay, it's at the root of this hierarchy is the root folder, and it's denoted with a /. So that / is literally a directory. So I can change to that. I can change to that directory, and I can type ls, and here's all the contents of that folder. It's an actual folder on your system. It has its own contents, it has its own subdirectories, its own files, and you can actually see here's the actual kernel. This is the Linux binary here. We can see that bin folder, that user folder that I went into here. So that's the root of it, and then directories can contain other directories, like the user directory. And in every directory, there is a special directory called dot, and another special directory called dot dot. And as you've seen when running C programs, this dot directory is really just a reference to the directory itself. Now, why would you want to have that? What's the point of having a directory that references to itself? I mean, you're already in the directory, right? You could like list it. Why might that matter? Well, think about it. We'll see some examples of why it matters. And then we have the dot dot directory. If we're, say, in user, and there's a bin folder underneath, and there's an application called ls, there's an application called like awk, there's all sorts of applications in here, and each of these folders have their own dot and dot dot directories. So users dot directory points to itself. Bin also has a dot and a dot dot directory. Now, what is the dot dot directory? Have you ever used this? Who's used the dot dot directory? Like cd dot dot? Where does that go? The parent folder, right? So this is just a reference to the parent folder. And same with this dot dot. It's a reference to the parent folder. So why might that be useful to have in your file tree? Let's say I didn't have the dot dot folder and I'm here inside of user bin. How can I change directory to the parent if I don't have the dot dot folder? Well, I'll have to type user. I'll have to do that myself. And remember, laziness is a virtue and patience is a virtue. So this is like a shortcut that references you to the parent folder. And yeah, bin points to itself. All right, questions on that? Questions on those conventions in the, yeah. Yeah, that's exactly right. So, so I could start. Let's go into some. I think there's some. It's in share. I think there's some like documentation stuff in here. I think. So here's some just text file called machines. So here you can see I'm printing out part of the machines. Cat just means concatenate, or it'll just print out text files. So if I say /machines, it's the exact same file. If I say // what file am I referring to here? The same file. Because if you look at our tree, when I say, if I have, say, the path // machines, and I'm currently in bin, the dot folder is going to take me right back to the bin folder. The dot folder is going to take me back. It's just like a cycle. It takes me back to bin. So no matter how many times I say // I'm still referring to the bin folder. Yeah. Oh, yeah, okay. Was that what you were asking? Oh, no, okay, yeah, that's exactly right. So if we look here and look for some directories here, so examples is a directory. So if I want to say print out something in the examples directory, let's see, reporter, I don't know what any of this stuff is. This is a different shell. Yeah, I can indeed say, let me clear the screen. I can indeed say cat and then the subfolder name and the reporter and whatever file it is. So for instance, if it's dot, I can put / before here as well. And / will just refer to the current folder. Now, by default, most of these tools on these command line tools will be aware of what your current directory is. This is called the working directory. And so any paths that you refer to are relative to that working directory. So basically all of these tools know, like cat knows that I'm in user, share, doc, zshell doc. That cat program is aware that I'm in that folder, and if I just say some file, it will append this, what's called this absolute path, this working directory path, to the beginning of this path. Make sense? Sort of? Okay, I'm going to talk a lot about file system more in later lectures. Okay, yeah, relative to that's actually the next thing in my guide here. All right, so absolute, yeah. Oh, thanks. Thank you. Yeah.
Just to make sure I understood what you said. So you said if we did cat and then a folder followed by a file in it, it would put that file in front of the folder?
So it will. So okay. So if I say cat, you can think of this working directory, as being effectively copied at the beginning of the path. You can think of it like it's being copied there in some sense. So running those two, where I have the working directory in front of the file that I'm trying to print, is the same file. It's referring to the same file. And so the difference here is that an absolute path is when you fully specify each folder from the root that leads to that file that we're interested in. So if I'm trying to say, look at the ls program, I want to find, so ls-l will just list the files. It'll list this program. If I put a / before my file reference, it's an absolute path, which means starting from the root, I refer to every subdirectory that I need to walk through in order to reach that file. If I don't put a /, like say I put no /, it's going to assume that I'm starting from my working directory. So if I say ls-l without a / user bin ls, that's equivalent to saying this, to taking the working directory and appending it to user bin ls. So quick quiz. This ... is this a relative path or a absolute path? Relative. Why? Yeah, there's no / that starts from the root. So if you give a /, the Unix convention is that you're providing an absolute path that starts from the root of the file system. Otherwise, it's assumed to be a relative path. Relative to what? Relative to the working directory. Yeah?
Is there a command that prints out the whole file system, or is that something we have to keep track of ourselves?
There is, yeah. So you can use the tree command, and this will print the entire file system for you if you want. So you kind of have to move a little away from the graphical mindset here. So you could do that, but most of these systems are going to have huge.
Is there a way to make that relative so it's not that big?
Yes, you can just run tree from the current directory. So most of these commands, if you just run the command like ls, that's equivalent to saying ls dot. So if I run tree, it'll show me all of the subtrees. There's also find, which does something similar. It'll list all of the files in your current directory and the subdirectory. And there's all sorts of options you can give to these commands to modify their behavior. So I could, for instance, say, only show me down 2 levels deep. Next step 2. Don't worry about these. These are like more advanced stuff. I can show you some tutorials where you can learn more about these. But yes, you can view your file system. And I'll show you also a cool trick to do this kind of on the fly while you're typing out file systems. There's like an autocomplete feature in Bash that's super useful for helping you navigate the file system. Okay, so that's absolute paths. How do you know when it's an absolute path in the Unix world? / starts with the /, otherwise it's a relative path. The working directory, we'll learn about this also when we go into processes, but your Bash and every process, every program that's running, the system maintains a current working directory for it. It actually lists some current working directory, and just like in Bash, and just like any process, Bash maintains this working directory. So when you're moving around this file system, say you're using CD to change directory, Bash will actually show you what the current working directory is by default. And this is stored by the operating system. The operating system actually maintains this folder. That way, whenever you go to do any file operations, it'll append that working directory effectively to whatever path you're providing it. So now, without a / user bin will work as expected here. It'll append this / to this path and list out bin for us. So here is, whoops, let me just look at the beginning of it so you can see. It's as if I provided the full absolute path to ls. Questions? Questions about paths? All right, here's another quick quiz. Let's say I'm in the ls directory and I list, or I'm in user bin, I made /user bin, and I list .. /bin. What folder am I going to be using here? What's that? Okay, I have the user directory. Any other guesses? Educated or otherwise? Any other thoughts? What's that? What's that? The same directory is actually the same directory that I'm currently in. Why is that? So when I'm in the bin, my current working directory is the bin directory. This is my current directory. And I follow the dot directory. Well, that's going to take me to user, right? It's a parent directory. And then I use the / to indicate another file in user, and that's bin. So this just takes me right back to bin. Kind of make sense? So if you think about this just tree, everyone knows trees, right? You've all taken like CS1, I think. So you've learned about trees. This hierarchy is just a tree structure. And this is designed by people. So not all file systems are tree structure designs. There are other kinds of designs. Most of the ones in the operating system we use are tree structures. And so if you know trees, and you know that .. refers to the parent, you can always take whatever path you see and work out exactly where on the tree the path is taking you. Yeah?
Using the names in this example, is it ever possible to have a bin folder and then a bin file so that you have to differentiate between which you're trying to access?
Not in the same directory.
Okay.
So as we'll learn about when we learn about sort of the API of the file system, directories are just files. Directories are special files that contain a listing of their children. So directories and files, directories are just files. So anything in a directory, they're all files. The dot directory, also a file, a special file that points to the parent. So no, there must be unique names for each file. Yeah?
Can you use 4 dots to go back to directories?
Yes, effectively, yeah. So we can say .. / And what directory will this take us to? The root. Yeah. So now we're in the root directory. So yeah, you can string these together as much as you like. So I can say ... to user share, and this is super confusing, but what directory am I in now? If anyone can guess, this is a share. Who says share? Who says user? We're in user. We'll get back to user. So we went to user, then bin, then the parent of bin, which is user, then the parent of user, which is root, and then user, share, and then back to user. So you probably won't encounter these kinds of paths that much, but just to exercise. Yeah. Yeah, you just use dot dot. That's right, yeah. So if I say change directory dot dot, that means first it means go to the parent, which is /user, and then I can go to a different folder under user. So this dot dot, you can think of it as replace. If you copy this whole path here, if you want to think of this as like kind of abstract operations, this is the full absolute path. Well, it's sort of absolute, and then dot dot is like kind of removing the previous folder in some sense. So this brings us to user share when we do that. And just to convince you of that, let me do so it brings us to the same place, user share. Is this new to some of you guys, some of this stuff? Okay. All right, so that's the file system. There's a homework tonight that'll help you, you'll get some exercise working with your file system. We talked about the working directory, parent directories. Okay, so navigating the file system. I've already shown you some of these, but let me go over some really useful ones. So this, one of your colleagues asked about visualizing the file system. So one useful thing to use is PWD, print working directory. Now this is here as well, but some shells may display your working directory differently, or you might have tilde, which means your home directory. PWD stands for print working directory. It'll just print out what the current working directory is. So if you ever feel lost, you want to know where you are, absolutely use PWD. If you want to see what's in the current working directory, or what's in the current working directory, use ls. ls is short for list. So you want to list everything in the current directory. So all these commands, they take arguments, as I kind of showed already. So if I do ls, and these are all specific to the tools themselves. So ls will take any path you give it, and it'll list the contents of that directory. So if I want to list the contents of my homework directory, I just put space and then the argument to the command. This is like the Unix convention for command line tools. And you'll see this in Windows and other operating systems as well. So I already showed you this already. CD stands for change directory. You've probably seen this in the Windows world or the Mac world. So if I want to change, and all it does is change the working directory of bash. So when I say CD, COP, etc., now my working directory is this folder, which means any commands like ls, which just use the working directory, will now operate on the current working directory. Any questions about these commands? So this is like all you need to kind of move around and look at your file system. PWD to see where you are, ls to print the listing of the current directory, and CD to move around between folders. Oops. And so, remember that these commands, they take paths. So you don't necessarily have to change, like if I want to move this make file or rename this make file, or let's say I want to copy it. I don't have to change directory into hello. I can just provide the full path to it and copy it here. And this actually, so CP stands for copy. And so this is an illustration about why having a dot for the current folder is so useful. If I want to say copy something into my current directory, well, it would be really annoying if I had to put my full path. I think it's this. It'd be annoying if I had to put the full path to the folder. I can just say dot to refer to my current folder. So this is one of the utilities of having a dot folder, is I don't need to type out the full name. And now makefile is here. Questions? Questions so far? So go to the parent directory. This is cd dot dot. So now you can see my directory is now the parent of the previous directory. Go to a subdirectory. We saw this already. You just put the name of the directory. All right. Any questions on those kind of fundamental commands, pwd, ls, cd, that'll help you navigate the file system. Okay, so let me show you how to make this fast. Now, it's really tedious. You've probably seen when I do this, it looks like I'm typing really fast. Like, I'm not actually typing all that out. I don't actually have to type all this out. There is an autocomplete feature in the command line. It's called tab completion. And it's just like autocomplete on your phone in some sense. And so this is the impatience virtue. So sitting there, and I've seen students, frustratingly having to type out every word in that file name, and they might get it wrong. Autocomplete makes it really fast to navigate your file system on the command line. In some cases, faster than even from a GUI application. And and it's also laziness because you don't actually have to remember file names. Okay, so let me take the example I have in the slides here. So let's say we wanted to list, so you as user include, this is where all your header files are for C programming, for your C APIs on your system. So let's say I knew something started with like GNUM, and I didn't feel like I wanted to list out the GNU make.h file. And I was too lazy to type the rest of the characters. All you have to do is start typing it and then hit tab. So you can't see it, but I'm hitting the tab key here. So I typed GUNM and then tab. Looks like I'm typing really fast. I'm not. The system is typing for me. Laziness, impatience. Make the system do work for you. Make sense? So just start typing the name and hit tab. And voila, it's filled it out for me. Now you might see a problem here. What if I start typing it and then there's lots of files that start with that GNU. Tab doesn't do anything, so you might be able to hear it. I'm typing tab, and it doesn't do anything. Well, if you type tab again, it'll list out all the files with that prefix. So you can at the same time do autocomplete and also visualize a bit your file system. It'll show you, if you keep typing tab, it'll just show you all the files that match this prefix. And then once I start, and then I don't have to type these out, I don't have to type, versions. I can just type whatever prefix is going to disambiguate this file, hit tab, and voila. Maybe this seems like a small thing looking at it, but this makes you incredibly fast at navigating the file system. So I was already doing this sort of subconsciously when I was navigating this, but I just use this all the time, just constantly hitting tab to move around the file system. And so let's say, if I were typing this out and I misspelled something, I put 1 instead of 2. It's going to be really annoying, right? And I'm like, what did I do wrong? I have to look through it. You don't have to do that. Instead, you can just start typing and hit tab repeatedly, and it'll sort of verify for you that this file exists. So if I typed it out correctly and hit tab, it'll complete the directory for me. And even better, I can use this to help kind of navigate the file system. If I keep hitting tab, if this completes and I keep hitting tab, it's going to show me not just files in my current directory, but entire paths in my system. So if I keep hitting tab, it'll show me whatever files I can continue to type out to complete this path. So if I type HE for hello, hit tab, and now hit tab again, it's going to show me, it's going to automatically go into the single directory that I have in there, because it's a single file I have. And if I keep hitting tab, it'll just keep showing me whatever subdirectories are available here. Make sense? Who's used this before? Who's actually used this? Okay, good number of people. Oh yeah, that's pretty good. So maybe like 12% of you have done this, but that's good. That's good. So you'll hopefully learn something. So this will make the terminal way, way, way less painful to use and way faster to use. Okay, yeah. So make it a habit to hit tab. It'll confirm the existence of a file for you. You don't have to guess the file name. I mean, you have to guess the beginning of it, but you don't have to guess whether you've typed it right. You don't have, if you're running like Emacs and you had a typo here. I said make file. Emacs is going to open a new file for you. So if you were trying to type a real file name, hit tab, and it'll show you what file names are available, and then you can make sure you pick the right file. All right, questions? Questions on this? So if you take anything away from the command line, use tab. Okay, so if you've done the Emacs tutorial, which I know like 99% of you totally have, there are some other commands that are from Emacs that'll help you navigate or move around your command line. I'll just go over these really quickly. They're they're going to be hard to remember. So there'll be something that you'll have to practice if you want to get fast at this. So let's say I'm typing a command here, and I get the wrong directory or I make a mistake. I can go home. You can either hit the home key, home and end key, or you can do Control A and Control E. Think of A as like alpha, the beginning of the alphabet. That's Control A is the beginning of the line. Control E for end, the end of the alphabet. So I can move back and forth. So let's say I didn't want to run Emacs. I wanted to run something else. I can just edit the command line without having to type it over. Another little trick that a grad school friend taught me is you can just put a hash mark in front of it if you want to hold on to the command and not run it, which I'll show you in a little bit, but you can actually repeat previous commands with the up and down arrow. But I'll show you that in a second. That's the history. Yeah, so backspace will delete stuff for you, but if you hit Alt backspace, it'll delete entire words for you. Yeah.
Did you do like an insert thing?
For
Like when you were typing out Emacs, did you like also do some insert?
You mean this?
How do you delete everything?
Oh, how do you delete everything? Oh, yeah. Sorry. Yeah. So, sorry, I didn't have it on here, but so Control D will delete a character. Did I not put it here? I didn't put it here. Yeah, I didn't put that variation of it. So backspace will delete a command, Alt backspace, or delete a character. Alt backspace will delete an entire word. And then to go the other direction, Control D will delete a character in front of you, like so. And Alt D, you can see a pattern here, right? So Alt, there's Control versus Alt. Alt D will delete entire words. So to show how I did this command, Alt A to go to the beginning, Control D to delete the entire word, and then type out. Yeah, so that's how it looks like insert, but I just deleted it really quickly and then wrote it. So you don't have to necessarily memorize all these, but these will also help speed you up on the command line. Bash is pretty universal on Linux systems, so if you learn a little bit of the Emacs commands, you'll also know how to work with the command line and just do things faster. Any questions on that? This is just, yeah.
How do you highlight certain words with just the keyboard?
So there's no real notion of, there's a notion of highlighting in the Emacs tool. But here, you mean highlight to like copy it or paste it?
Copy, paste, delete it.
Yeah, so again, look at the Emacs tutorial, but the way in the command line works, there's no real notion of highlighting, as far as I know. Instead, what you can do is when you delete words, like with Alt Delete, it gets saved into a buffer, and then Control Y, yank is the mnemonic for that. Control Y will paste. So if you use Control D to delete something, Control Y will paste it. Look at the Emacs tutorial. It goes through all these commands, but there's no real notion of highlighting.
Control D like cut.
Control D is like automatic cut in the command line. In actual Emacs, Control W is like cut or copy in Emacs. But yeah, the command line you don't have a notion of highlighting. Emacs you do, but yeah, you can delete and then paste once you delete it. So Y for yank. But good questions. Look at the Emacs tutorial. It'll walk you through these commands. Oh, I did have it. I did have the Control D. So to Control D to delete a character, Alt D to delete an entire word. So yeah, Control F and B go forward and back. You can use arrow keys as well. But if you use Alt F and Alt B, it'll do whole words. So you can kind of see this pattern here. Control is for single characters, Alt is for whole words. And you can, FB, forward, back, D, delete, A and E, beginning and end. Anyway, you don't feel like you have to memorize all these now or work through this. You can kind of gradually learn this. Or don't. You can just use the arrow keys, home and end. But just want to show you what's there for making things fast. A couple other commands. Control K for kill or cut. This is like cut for cut and paste. So you can combine this with Control A to go back to the beginning of the line. So I can cut the whole command here. Maybe I wanted to do something else before that. And Control Y will yank or paste. And I already showed you Alt backspace and Alt D. So Alt backspace deletes whole words. Alt D deletes whole words from the other direction. Yeah. Semicolon just separates commands. Yeah, it separates commands. Yeah, sorry for throwing that in there. All right, the kind of second most important or useful like space. Oh yeah, go ahead.
I just wanted to ask, so what is, because you can highlight it, like when you drag.
Oh yeah.
Yeah, so what does that do if you can't actually interact?
This is, so right now I'm connected to a remote server, and all these commands I'm running are being processed on that server. So bash is a program running on the Eustace machine. When I'm doing highlighting, this is happening on my local machine. So this highlighting is happening via my SSH, my terminal program.
Is there any way you can drag the highlighting? Or is that
On my system, yeah. On my system, I can locally copy with Control-Shift-C. I don't know if Windows does this, and then I can use Control-Shift-Paste to paste. So I can do that, but that's not happening on the server. That's happening on my local machine, yeah.
So Windows is weird, and I was actually gonna ask if you knew about this. On Windows, at least what I find is you have to right-click because Control throws a bunch of junk characters.
Yeah, so Windows, it doesn't work like this. My terminal windowing system does let me do like copy locally. So if I like, so for instance, if I put this word less here and I cut it, I can paste it here on the remote server, but if I try to paste it in my local machine into this browser, you can see, well, it's hard to see, but you can see it's what I cut and pasted here. So if I like just copy this net line here, I can paste that on my local machine because I'm copying it from my local machine. Does that sort of make sense? Yeah.
For the guy that was making a comment about
Yeah.
Windows, that's a setting you can change.
It's a setting you can change to be able to do it. Okay.
Control V, right?
So yeah, if you want to do
Where do you
local.
change that?
If you're using terminal or some process.
So you all should have access to EdSTEM now. So great question for EdSTEM, or if you want to like help out your fellow students, you can put a message on there and say, hey, here's a tip on how to do local cut and paste on your machine. Yeah. Mac, I think it's Command C and Command V, but again, these are local. This is local cut and paste. But yeah, you'll need this. Well, you can use this when you're doing projects. You can cut and paste commands from the projects instead of hand typing them into the terminal window. But yes, this is local. This is not via bash. Your local system is like simulating your keyboard presses into the terminal window, and those are being read by bash running on Eustace. All right, a lot of interest in this. This is cool. Everybody's asking questions about that. Okay. All right. So the other really useful speed hack is, especially when you're, say, working on a program, you may have to type out some long command. Long for me is, if it's like more than 3 characters, that's kind of annoying to type out. So you might be typing out some long command and repeatedly running and then typing out your compile command. Well, if you just want to repeat an existing command, you don't have to do that. You can use bash's history. So the history command will actually show you your whole list of commands that you've run that it's saved. Actually, not just in this session, but it'll actually save them over time. So yeah, it'll save all the commands that you run. And if you want to access these quickly, you can use the up arrow or Control P and N, next and previous. But you can use the up arrow to just rerun, cycle through all of the commands that you have. So I'm just hitting the up arrow here, cycling through all the previous commands that I've run. So if I just want to rerun and compile hello world, it's extremely fast for me to do. Extremely fast for me to do that. So I can just compile, run, compile, run, compile, run. And I can do that really fast without having to retype any commands. Yeah.
When you use history, you type it to tail. What happens if you don't do that?
It'll just show me the whole history. So tail is a program that means just show me the end of a file. Head is a program that says show me the beginning of a file. Yeah. Oh, that's a good question. I think it keeps it in the history. Yeah, it keeps it in the history. Yeah.
Can you clear the history?
You can clear the history. Well, it's just in a file here, bash history. And you can also turn off recording of history. I think it's an environment variable, yeah.
Can you run a series of commands from history, or do you have to do them one by one?
Ooh, it's a good question. I don't think you can run a series of commands. I don't think so. You could kind of collect them. So something I do is cut them, and then paste them. So sorry, that was probably a little fast, but so I have these two history items. I could like cut one using Control K, move down the history to another command, and then combine them with semicolon. This is getting probably a little ridiculous to show, but yes, there are tricks you can do. This is file, so you could go into the file and construct a script from it. But yeah, I don't know of any way to do multiple commands. Yeah.
Do you use semicolon to run two commands, or do you use the vertical colon to run two commands?
They both run two commands. Pipe is something different that we'll talk about. It does I/O redirection, but I'll talk about that. I don't think I talked about it here. I'll talk about it when we get to processes. You'll actually see. I'll actually show you this. This is like a unique feature of Unix. That's what allows you. It's kind of like allows you to put programs together, like Lego blocks. But yeah, don't worry about it right now. I'll show more of that. Yeah. So command history, up or down, Control P or Control N. This is also a little more advanced. I don't know if you will have use for this, but if you want to search for a previous command, Control R. You give Control R for reverse search. I can start typing the command, and it's like kind of like autocomplete in your history. It'll bring it back. But be really careful here, because if you hit Enter, it'll immediately run it, which you may not want to do. So a little trick, go back to the beginning of the line, put a hash there for a comment, and you've now sort of bumped the command up to the top of your history. Or you can use Control G to cancel the search. All right, anyway, these are sort of more advanced things, but the main things I want to just make you aware of is tab completion to help you navigate the file system and write paths really fast, and history. And these two things will just reduce your typing amount by an enormous amount. And you'll start seeing that there's really simple workflows. So like open your editor, pause your editor, compile, run, open your editor, do your edits, pause, compile, run, and you can do that workflow extremely fast on the command line. Even faster than using a mouse. Even with an IDE, I would argue. All right, any questions on history, tab completion? All right, let me show you a few more commands. So cat is short for concatenate. This will print out individual files. It'll take the file that you give and print it out to the terminal, the console. So it's called concatenate because you could give multiple files here, and it'll print them all out at the same time. More, if the file is really long. So let's say the script here. That's not a good file to use. Let's go back to that documentation. Oops. Where did my cursor go? So I typed the wrong thing, and I'm just using tab aggressively to figure out where I am. Okay, so if you do cat on some really long file like this machines file, actually that's not that long. Let me find a longer one. README is probably long. So you could like scroll up depending on your terminal, but a more Unix way to do it is to use the more command. So more will only fill each screen one screen at a time with the contents of the file, and you can hit space to list through the file. A fancier, what's that? You cannot go back with more. So there is an updated command called less. Less is more is the pun here. So opposite of more. So less will let you move up and down. So it has commands that are like Vim, another editor, but you can use arrow keys, page up and page down, and this will allow you to go up and down in the file, kind of like a viewer, like a text file viewer. This one you got to be a little careful with because escaping is not so easy. Use Q to escape by itself. Use the Q command to escape. Oh yeah, it says it here. So Q to quit. But yes, less is more. Less will allow you to navigate the file. Yeah.
What's the difference between cat and less?
Less. So cat will just print it onto your terminal, no matter how long it is. Less is an interactive program that'll allow you to navigate the file. So I'm moving up and down using the arrow keys here.
it's not printed onto your command.
Yeah, not onto, well, it's not onto your screen.
On your, like on your.
Not in its entirety, yeah. So if I were to cat the README here and I scroll up, you'll see my entire terminal window has been filled with the whole file. But if I do less, and then I quit immediately, then you'll see, well actually, it clears the whole screen for me.
Yeah.
I could like Control C to, I can't even quit. Yeah, it won't even let me. It'll clear the screen for me, so it won't even pollute your terminal history with it. There's probably a way I could like kill it or something. No, it clears the screen. So yeah. All right, that's cat, that's less. There's instructions for navigating less. I know it's more commands. All right, so everyone should have completed the Emacs tutorial, but I'll just go through it really quickly since at least in the beginning you'll be using Emacs for editing files. Oops. So Emacs, just like any command in Unix, you type the command itself, a space, and then the file name you want to edit, a path to the file you want to edit. So I can edit these files from anywhere. And it has really similar commands to Bash itself. So Control P and N for previous and next, or just use the arrows. Use the arrows to move around. And you can use all those same commands on the command line, like Control K to kill, Alt D to delete, Alt backspace to delete whole words. It really has the same kind of commands as Bash. All right, questions so far? So just kind of a crash course in the command line. Do you feel a little more comfortable using the command line now? Maybe. I hope. I know you can use the notes as kind of like a reference. I don't expect you to like retain all of this now, but some of the quick. Oh yeah. So one trick with the editor. So I was talking about this workflow where we compile and run the program. So if I compile and run, we can put the editor in this workflow as well. So if I want to edit this program, I can type Emacs, and let's say I made a little mistake, like maybe I forgot the new line character, and I just use my history to go back and recompile and rerun the program. You can see, hello world's missing a new line. That looks very ugly. So if I don't want to have to re-enter my editor, I don't want to have to type Emacs again and then move down, move down hundreds of lines potentially to the line that I was editing. There's a trick you can use where you can pause a program. You can pause the editor, and this is done with Control Z. So question?
Sorry, I was just messing around with the less function on my terminal.
Yeah.
And it doesn't read PDFs, it just shows you in binary. So what kind of files can you read with less?
Text files. There is a feature in Less where you can, it'll automatically pipe a PDF to a converter, but it's text files. So PDFs are not text files. They need a renderer to graphically render it. So Control Z will pause your editor. So if I hit Control Z, you'll see it says stopped Emacs. So to return to it, FG for foreground will bring it back to the foreground. This is like sort of like windowing or multiprocessing in your command line. So you can see if I print out this hello file, that change that I made, I didn't save it yet. So you can see my editor's still running. I haven't lost my changes yet. Once I save it, Control X, Control S to save. This is going to be in the tutorials. Now you can see I just paused my editor, print it, now it's saved. FG to go back to your editor. And you can see my cursor's still on the same spot. I don't have to move around my file again. I don't have to scroll down hundreds of lines. And I can integrate this into my workflow. So I've got compile and run, foreground to make changes. Let me go make the fix to add this new line character, save. Instead of quitting, I just pause my editor, use the history to very quickly go back, and voila, there's my workflow. Compile, run, change. Super fast workflow you can do right on the command line. So if you forget about it, so I didn't show this, I'll show this when I go to processes. You may accidentally edit multiple versions of this. You have multiple ones paused. You can see with PS, if you have multiple ones running, you can just type foreground repeatedly until you close all of the open ones. Now remember, this is running on the server, so if you have some unsaved changes in there that's paused and you get disconnected or the server goes down, you've lost those changes. So save frequently, which is like true of any programming. Save and back up frequently. We'll look at version control next time. That's how you effectively will back up your source code. But yeah, there's useful fast workflow in the command line.
Just Control X.
For saving,
Yeah.
Control X, Control S, Control X, Control S. Is the Emacs way. Yeah.
Can you do foreground by process ID?
You can do foreground by job ID. So if I have multiple ones open, the jobs command will show me which ones I have open, and then you can say foreground and then the name of the job. And this will bring up, that'll bring up the make file. FG1 will bring up the C file. Don't worry about that too much. If you just stick with this simple workflow with Control Z and foreground, you can just very quickly go back and forth between compiling, running, and editing. Was there another question over here? All right, yeah.
How are you closing it out of Emacs?
Out of the editor, so Control X, Control C. So when you have to use Emacs in the exercises, I'll tell you the exact commands in Emacs to run. So Control X, Control S is how you save. Control X, Control C is how you quit. And it's listed in the tutorials I give you. So I'll walk you through, like, it's really paint by numbers using the command line for the first few exercises. All right, so I'm going to close these. Okay. Oh yeah, question?
Sorry.
Yeah, no.
How do you, is it possible to refresh the command terminal? Like just refresh the page with key arguments on it? Because like once you resize it, it's still, all the letters are still like.
No, I don't think so. I think you just have to do Control L to refresh. Yeah, it's not. It's not going to redraw the history of your script, unfortunately. Yeah, resizing causes problems because it makes assumptions about the width of your screen. Emacs you can redraw. If you Control L is the same command in Emacs. So if I were like, well, it's redrawing automatically anyway, but Control L will redraw the screen if something goes wrong. Other questions on this stuff? I know there's like a ton of information and it's super practical information, so I don't expect you to memorize it now. But yeah, the homework tonight will give you some comfort with the command line. I give you the exact Emacs commands in the first few exercises. And then let me show you a few more commands that'll be useful for tonight's exercise, because you'll do it entirely on Eustace. And I'm going to give you some file system hierarchy, some file tree for the homework. So let me actually show what the homework is first. So for this homework, you'll take an existing file tree that I've given you, and you'll use commands to edit the file tree to change it into a new one. So they look really similar here, but if you look closely, some stuff has changed. So this FS directory this ext2 directory is renamed to ext4. So it's a little puzzle solving exercise. So kind of spot the differences, and then use the file system modification commands to change one file tree into another. So this will really force you to start using the command line, use tab completion to help you navigate the file system. But in order to get this file tree that I've created, you'll download it from the internet. So what's really cool about the command line is you can do internet browsing, you can do email, you can do calendars, all from the command line. So for instance, the Linux developers who build and maintain the kernel, it's like a 20 million line program that probably billions of devices are using currently. Most of those developers, they do everything on the command line. They do email on the command line. All this stuff is totally possible. So there's a command here that will download files from the internet for you. There are several of these. One is called wget. I guess, I don't know, website get. I'm not sure what it stands for. But wget, and then you just give the URL. It's a good idea to put these in quotes, single quotes, for text processing reasons. And so let me show you that command. So you can really just copy it from the homework, if you like. So this is the whole command. So I copy and paste it in here. It's just wget, and this is just an option that, well, this is a convention in Unix tools. This is an option to say, save it to the homework2.tar file, and then I just put a URL in here. And you can use this to download any file you want from the internet. I mean, you can don't do this, but you can scrape websites from the internet using this tool. You might get banned if you do that, but yeah, this tool will rapidly download enormous amounts of files automatically from the web. Okay, so I run that command. Gives you a little feedback information. Actually gives you a progress bar, which is pretty cool. And now we've downloaded this file, which was now on my server, and now it's on your local machine. So it's here in your home directory. Oh yeah, I forgot to mention, I thought it was in the slides somewhere, but this tilde, it's probably a little hard to see here, but this symbol here, this is a tilde, and this is just an alias or a reference to your home folder. So every user on Unix systems by convention is given a home folder. I can type pwd to see what it is. So this is my home folder. That's where you can use your own files, create your own files, run your own programs. Tilde is just a shorthand for that. So if I type ls COP-3402 fall 25, that's the same thing as typing the full home folder name. So same thing. That's all tilde means. So when we saved this file to tilde hw2.tar, this is just saving the file to your home directory. Okay, so there I've downloaded the file from the internet. This is a tar file. It's like the Unix world's equivalent of a zip file, although it doesn't do any compression by default. It's like an archive that you can put any files into. And so to unarchive it, the instructions are here as well. We use the tar command. And don't worry too much about what all these options are. I'm not going to quiz you on these. Oops, I went into developer mode accidentally. So this command will just unpack this tar file, and now you'll have a folder called homework2 that you can change directory to. And that's where you'll start doing homework 2. That's where you'll start moving files around, creating files, deleting files, to make the new tree match the required tree in the homework. So let me walk through the commands that you'll use for doing the homework. So these are the only commands you'll need, and let me explain to you what each of these are. So touch you can use to create a file. So if I want to create a new file called Bob, touch has now created a new file. Remove or remove a file, RM for remove, or remove a file, Bob. Now it's gone from my directory. Move, you give the original name, like HID, and its new name. So now I've moved HID to the file HID. Copy for file, so if I want to make a new copy of this make file. So I give the original file here and then the name of the new file. You can see now I've got this makefile.new, but the original makefile is still there. So notice there's no rename command here, like Windows has a rename command. How can we rename a file? Move, yeah, use move, exactly. So move and rename are the same thing, except move can also rename stuff. It can also move stuff to other directories. But if you use it in the same directory, it's effectively rename. And then creating and destroying directory files is different from creating regular files. So mkdir will make a new directory. So this is my new directory. I can make subdirectories like so. So now I've got this new directory here, and inside of new directory is my subdir that I created. And you can remove directories with the rmdir command. So I can make another directory called Bob. One caveat with remove directory: if that directory is not empty, the system will not empty it for you. That's just kind of a safety mechanism. It won't remove the directory if there's other files that exist. You can remove entire file trees. Look up the command yourself. I don't want to show you. It's a little risky because you might just delete whole file trees accidentally. But the way to do it carefully is to just go through and delete all of the files inside the directory, and then now I can delete the directory. And you can think about what the algorithm would be for doing that automatically. Just a tree walking algorithm. All right, so I went over that already. Yeah, so just a little review. All right, questions on the homework? Yeah.
So when we download the thing that you gave us, we're gonna have that file tree already.
Yeah.
Updated?
Exactly, yeah. You'll just use those 6 or 7 commands to update the tree to match the after one here. Yeah. No, just homework 2. Yeah. Yeah, that's right. All right, everyone. Have a good weekend.
Mr. Gazillo,
Hi.
am I saying your last name right?
Yeah.
Okay, nice to meet you. I'm Kyle.